Okay, here we go with pre-calculus, page 384, going over the problems that were due, well, when were they due? Last Friday, I think. I don't remember now. We may or may not get to new material for today. As you know, we now only have class on Mondays, Wednesdays, and Fridays. So if I don't get something new to you today, which is Monday, you'll have to wait until Wednesday, you poor things. Now, moving right along here. Okay, number 44. Cosine of theta is 3/5. We know that, and we're in quadrant 4. So we're down here in quadrant 1, 2, 3, 4. We know the cosine is 3/5, but we don't know the angle. Who cares? We don't need the angle. Draw an old triangle here, any old place. Doesn't matter what the angle is. This is your unknown theta. We know cosine is 3/5. We resort back to our old friends, so katawa. We know that cosine is adjacent over hypotenuse. So we can fill in an adjacent, which is this guy, of 3. Let's make that look better. 3. And the hypotenuse of 5. Now, we could use Pythagorean theorem, a squared plus b squared equals c squared, to figure out the remaining side. But you should know by this time in your high school experience that if you've got a hypotenuse of 5 and a leg of 3, the other leg has to be, yes, I heard that. Oh, I heard it from several of you. 4, indeed. So we now know everything we need to know. From there, finding the remaining functions is no problem. Why did we care that we're in quadrant 4? Oh, I used to, quadrant 4. Why do we care that we're in quadrant 4? Because that tells us the signs. It tells us that this adjacent, or so the opposite side here is a -4. But we could also get that from all students take chemistry. We know we're in the 4th quadrant. In the 4th quadrant, all students take chemistry. Cosine is positive. We're looking for cosine, so my answer has to be positive. Wait a minute, hold on a second. Quadrant 4, cosine 3/5. Cosine, yes, 3/5. Okay, good. Cosine, all students take chemistry. We're in the 4th quadrant. Oh, it's positive. Yes, okay, I'm just getting myself all confused. So this side is negative, but the cosine of 3/5 is positive. Okay, I'm sorry for that delay there. My brain just went out the window. Okay, so continuing from there, sine being opposite over hypotenuse, sine is going to be -4/5. So sine is -4/5. We'll put it right here, -4/5. Cosine we already have. Tangent is going to be opposite over adjacent, right there. So tangent is going to be -4/3. -4/3. Then cotangent is just the reciprocal of that, which will be -3/4. -3/4. Secant will be the reciprocal of cosine, which is going to be 5/3. And cosecant is the reciprocal of sine, so we get -5/4. And we're done. That was easy enough, assuming I didn't make any more careless blunders like getting all messed up about cosine being positive. Okay, number 48. This time we're told the cosine is 4/5, which tells me what? Cosine is positive. All students take chemistry. So if the cosine is positive, we must be down here in quadrant 4, or quadrant 1. But this already tells us the answer to that whole question. Theta is between 270 and 360. Well, where is that? Here's 270, here's 360, so we already knew we were in quadrant 4. So we are in this quadrant 4. So we'll draw a triangle. Again, don't care what the angle is, doesn't matter. Cosine is 4/5, so the adjacent over the hypotenuse is 4/5. And again, if you know your right triangles, you realize that if that's 4 and that's 5, this has to be 3. And that gives us all the remaining functions. Tell you what, to save time, I'm not going to go through them all. I know you're quite capable of figuring out sine, cosine, tangent, cotangent, secant, and cosecant on your own without me writing them all on the board. Number, that was 48 going on to 52. With this one, we know that cosine is negative. Where will cosine be negative? All students take chemistry. Cosine is positive here and here. Therefore, we could be in this quadrant, we could be in that quadrant, where cosine is negative. But we're told the tangent is positive. Well, where is tangent positive? Tangent is positive here and here. The only quadrant that satisfies both of these requirements is quadrant 3. So we have to be in quadrant 3. So we'll draw our triangle in quadrant 3. Now, we know the cosine is negative 1/4. Cosine, so katoa, adjacent over hypotenuse. Adjacent over hypotenuse will be negative 1/4. From there, we have to go a little more trouble than we went to on the previous example. We've got to use Pythagorean theorem. So our a and our b values are negative 1 and the unknown. So we have negative 1 squared plus my unknown squared equals c, which is always the hypotenuse, squared. Of course, that's going to be 1 plus b squared equals 16. Subtract 1, b squared is 15. Take the square root, b is plus or minus square root of 15. Of course, we don't have to worry about plus or minus. We already know that this value is negative, so it's strictly negative square root of 15. The positive makes no sense in this context. So we got a negative square root of 15. So from there, again, I'm not going to torture you with going through all the answers. Perhaps I can simply give them to you. And remember, you're not allowed to leave a radical in a denominator. That is still true. So answers for number 52, we have sine is negative square root of 15 over 4. Cosine, negative 1/4. By the way, I trust you have your papers handy. Don't email them to me and then throw them away. Keep them until we have a chance to go over them. Tangent is just square root of 15. Then cotangent, what is the reciprocal of square root of 15? It's 1 over square root of 15, but you can't leave it that way. We multiply by square root of 15, there we go, over square root of 15, which gives us square root of 15 over 15. By the way, please don't forget, square root of 15 over 15. Can you cancel those 15s? No. Why can you not cancel them? Because that's not a 15. Don't be silly. It's not a 15, it's a square root of 15. You can't cancel a square root of 15 with a 15. That's silly. All right, moving on. Let's see. Did I give all the answers yet? No, I didn't. 52. So cotangent is square root of 15 over 15. Secant is the reciprocal of cosine. That's easy. Negative 4. And cosecant, again, you've got to get the radical out of the denominator. You end up with negative 4 square root of 15 over 15. All right, that takes care of 52. We now go to 56. For this one, cotangent is positive. Where will cotangent be positive? Well, all students take chemistry only tells us about those 3 fundamental functions, sine, cosine, tangent. But it also applies to their reciprocals. As we all know, cotangent is the reciprocal of tangent. Where is tangent positive? Here, and here. So this fact that it's positive 4/3 puts us here or here. The fact that cosine is negative, where will cosine be negative? Cosine is positive here and here. Cosine is negative here and here. That puts us in quadrant 3. So we are right now in quadrant 3. So knowing that, this is number 56. Draw our little triangle. There's our theta. We know cotangent is 4/3. So cotangent, the reciprocal of tangent. Tangent is adjacent over hypotenuse. No, it's not. Tangent is opposite over adjacent. If tangent is opposite over adjacent, then cotangent must be adjacent over opposite. They are reciprocals. So I want the adjacent, which is negative 1, over the opposite, which is also negative 1. So cotangent of 4/3, the others from there. If this is negative 1 and that's negative 1, what's the hypotenuse? To figure that out, Pythagorean theorem quickly. If we've got 1 squared plus 1 squared equals c squared, that's going to be 2 equals c squared, so c must be the square root of 2. You might remember that from geometry. And given that, you can find everything else. So, for number 56, sine is. Why does that not make any sense based on the answers I'm seeing here in my cheat sheet? What did I do wrong? Where did I get these numbers? Oh, Mr. Beer, I have no idea where I got those numbers. I just made them up out of nowhere. Sorry about that, folks. Some of you are sitting there watching this video thinking, Mr. Beer's gone crazy. Yeah, he has. I don't know where those the negative one came from. I just made them up out of nowhere. Cotangent is 4/3. So, again, reciprocal of tangent. Opposite over adjacent would be 4/3, would be 3/4. So opposite over adjacent is 3/4, and that looks a whole lot better now. And that becomes much easier. No Pythagorean theorem required, because we know if we got 3 and 4, this has to be 5. I don't know where that -1 and -1 came from. I have no idea. Okay, so from there you can find all the remaining functions. Your answers are sine is -3/5, cosine is -4/5, tangent is 3/4, cotangent is 4/3, secant is -5/4, and cosecant is -5/3. Now we move on to number 60 and see if I can avoid any weird, careless blunders. Okay, different situation going on here. We're looking for cosine of -30. And the instructions give us some encouragement here. They say do not use a calculator. Okay, no big deal. We're simply looking for cosine of -30. All right, remember this pattern. We saw this pattern spelled out for us at the bottom of page 382. You should have your books handy. If you write these in their natural order, what I call natural order, sine, cosine, tangent, and their reciprocals right under them, reciprocal of sine, cosecant, reciprocal of cosine, secant, reciprocal of tangent, cotangent. Then if you've got sine of -theta, for both of these guys, you take the negative sign out and put it on the side, you get negative sine of theta. Likewise, negative cosecant theta. Same thing with tangent and cotangent. Just take the sign out, it becomes negative tangent of theta. And it becomes negative cotangent of theta. But these guys are different. Cosine and secant are different. For cosine and secant, the really cool rule here is you simply drop the negative sign. And this will become secant of theta. Just drop it. It disappears. You can survive without these rules by looking at your unit circle. To remember this, just keep in mind when they're written in their natural order, it's the one in the middle is special. You just drop the sign. The other guys, you take the sign out to the other side. So what's that tell us then? That cosine of -30 is the same thing as cosine of 30. So here's our 30-degree triangle. Remember the ratios here. If the hypotenuse is 1, your short leg is 1/2, your long leg is square root of 3/2. Cosine being adjacent over hypotenuse, that's adjacent over hypotenuse, so your result is square root of 3/2. Square root of 3/2. And since I'm making careless mistakes today, I'm going to check that answer. That is correct. Number 64. All right, for cosecant, remember we have sine, cosine, tangent, and the reciprocals. Where is the reciprocal of sine? Right down here, cosecant. So for cosecant of -30, we take this negative sign out to the side, so this becomes negative cosecant of 30. What is the cosecant of 30? Well, here's 30. If that's 1, this is 1/2. This is square root of 3/2. Sine is opposite over hypotenuse. The sine of 30 is 1/2 over 1. But cosecant is the reciprocal of that. So cosecant of 30 is 2. But this says give me the opposite of 2. So we have a final answer of -2. No, excuse me. My seasonal allergies getting to me here. I have to emphasize that so folks don't think I have corona. Okay, that was 64 is -2, correct. We're moving on to 68. 68, sine. Once again, the negative sign just comes out. We get negative sine of pi. But what is negative sine of pi? Where is pi? Pi is on the axis, of course. So we draw a little pretend triangle here, recognizing that the opposite side here is 0, and the hypotenuse is always 1, and the adjacent side is -1. Again, you can get away without worrying about the signs if you use all students take chemistry in the end. So what is the sine of pi? Sine is opposite over hypotenuse. Opposite over hypotenuse is 0. Then take the opposite of 0. Hey, wait a minute. Yes. Isn't the opposite of 0 simply 0? Yes. You get 0 for number 68. And number 72. 72, sine for sine. We just take that negative sign and pull it out to the side. There it is. Now we find 3 pi over 2. Where is 3 pi over 2? Remember, we have 0, we have pi. This would therefore be a half pi. So we have 1/2, 2/2, and 3/2 pi. So 3/2 pi is down here. So it's on the axis, therefore we just draw a little imaginary triangle here with an adjacent side, the adjacent side of 0. The hypotenuse would be, here's the hypotenuse is 1, and the opposite side is -1. So we want the sine, which is opposite over hypotenuse. That's going to be opposite over hypotenuse, that's -1. But I want the opposite of -1, so our final answer is +1 for number 72. And we move on to number 76. Cosecant of -pi/3. Cosecant, again, aren't they going to give us any examples in these by 4 problems where we just drop the sign? Maybe it happens in one of the remaining problems, I don't know. But so far, once again, cosecant, reciprocal sine. What's the rule for sine? Sine says take the sign out. Hey, that's a way to remember it. Sine says take the sign out. Okay. I don't know if that helps. So we have the negative sign over here now. We want cosecant of pi/3. Where's pi/3? It's 60 degrees. Remember we have pi/6 here, and pi/3 up here. Pi/3 radians. All right, for a 30-60 triangle, if that's the hypotenuse, the short leg is 1/2, and the long leg is square root of 3/2. You need to know those ratios, by the way. Those are the ones you have to know. The 30-60 ratios and the 45-45 ratios you must know. So you don't have to be trying to figure them out on your own. All right, so where were we? We're looking for a cosecant, which means we start by finding the sine of 60, or the sine of pi/3. The sine of 60 being opposite over hypotenuse will just be square root of 3/2. There it is. Therefore, the cosecant is the reciprocal of that, which is 2 over square root of 3. But then we have to simplify by multiplying by square root of 3 over square root of 3 gives us 2 square root of 3 over 3. But then we got 2 square root of 3 over 3. But then we have to remember to take the opposite, which gives us -2 square root of 3 over 3. Number 80. Oh, I like these. These are kind of cool. You like these? I had no idea what to do with this. Not bad at all. Just think of your identities, those identities that you are supposed to be memorizing. What is cotangent equal to? Cotangent is the reciprocal of tangent. So let's rewrite this as tangent of 10 degrees times the reciprocal of cotangent, which is this. I shouldn't say the reciprocal of cotangent. Cotangent is the reciprocal of tangent. So what happens here? 10 degrees. What happens? Rather obviously, the tangent of 10's cancel. We're left with an answer of 1. Tangent of 10 times cotangent of 10 is 1, because these are reciprocals of each other. What happens anytime you multiply reciprocals? Reciprocals multiplied always give an answer of 1. So we could have seen that from the very beginning. Oh, aren't these reciprocals? So they have to multiply to give 1. And we go on to number 84. Tangent of 200. This goes back to another concept that we haven't reviewed since sometime last week. And that is tangent, as well as sine and cosine. Tangent is a periodic function. It repeats itself how often? Tangent repeats itself every pi, or every 180 degrees, which means I can subtract out any multiples of 180. So if I subtract out 180, I find that tangent of 200 is the same thing as a tangent of 20 times the cotangent of 20. And again, hey, these are reciprocals. Yes, they are. Therefore, you multiply reciprocals, you're once again going to get an answer of 1. 84 is again 1. And we move on to the last problem. Wow, we made it in record time here. All right, we need to fix this guy. Now remember, sine and tangent, sine and cosine. Sine and cosine are also periodic, but sine and cosine have a period of 360, or sine and cosine have a period of 2 pi. So we can subtract out any multiples of 360, or we can subtract out any multiples of 2 pi. Well, if I subtract out 360 from this, I'm left with what? I'm left with the cosine of 70. I trust. 360, yes, I do. So this actually becomes, I'm just going to erase and change this into negative 70. But wait just a moment. Cosine is that one where if you've got a negative angle, you can simply drop it. So this becomes cosine of 70. By the way, you could have seen that on the unit circle for yourself. If you figure out where in the world is, what was that original angle? Where in the world is 430? And just go around 430. This would be 180, 360. You can find it yourself. And that'll answer all the questions. But it's easier if you simply subtract out 360. So what's special about this? Oh, by the way, let's take care of that negative sign. With tangent, sine, cosine, tangent, this is the one where you drop the sign. These guys are the ones where you pull the sign out. So this becomes ordinary 70, but it changes the plus into a minus. Pretty cool. We just took the negative out. And what's sine over cosine? Another one of those fundamental identities you have to know. Sine divided by cosine is tangent. So this thing breaks down to nothing more than tangent of 70 minus tangent of 70. Could that possibly be equal to 0? Yes, it could be. And we are done. All right, be sure, whether it's today or Wednesday, be sure, well, I guess what is the definition of today? It depends on when you're seeing this. But make sure you watch for the video of the new material. We will indeed be moving on to section 6.4 in the next video. Watch out for it, and we'll be there shortly. For now, we're done. Thank you. Goodbye.